Before we jump into the declaration, it is convincing to figure out what atom gas petals are. The Tremendous Hadron Collider, LHC, worked by CERN, is a 17M ring of superconducting magnets. Correspondingly, it is the world's most unmistakable and most vital iota smasher. It represents the zenith of human accomplishment. Truly, it's strong to such an extent that it could replicate the specific conditions of the main second in the world. Yet, could this machine, intended to unlock the secrets of the universe, hold the key to something more forbidding? CERN, established in 1954, is one of the world's most famous research organizations, with 23 member states and countless specialists. It's a hub for collaboration and development. The LHC is CERN's focal project, but it's just one part of a giant network of gas pedals and experiments. Imagine a course not for vehicles or planes, but for subatomic particles. A test of precision, endurance, and space itself. The LHC speeds up protons to nearly the speed of light, sending them on a collision course that mirrors the energy of the universe just after the Big Bang. The impacts create temperatures much hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a specific purpose, exploring various aspects of particle physics. Together they act as massive cameras, capturing images of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also called the God particle, and other anomalies that could reveal clues about the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. However, with every answer comes another question, and with each discovery, a new challenge arises. The LHC isn't just a scientific instrument, it's a testament to human curiosity and progress. It represents our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the deeper, existential questions that emerge. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human understanding are constantly challenged, a revelation has emerged that sends a shiver down the spines of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a respected voice in particle physics, recently made a statement that has left the world both fascinated and uneasy. Cox's words resonate with chilling clarity. The goal of CERN's Large Hadron Collider is to recreate a small Big Bang. Yes, you heard that right, a miniature version of the very event that birthed our universe. The physicist further explained the implications of this goal, highlighting the LHC's remarkable potential for groundbreaking discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that constitutes a significant part of the universe. Imagine harnessing the power of creation, the ability to grasp the very essence of the universe. It's a tantalizing possibility, but one fraught with peril. The miniature Big Bang is not a theoretical concept. It is a tangible phenomenon within the LHC. The temperatures, the pressures, the raw energy, all replicate the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the genesis of existence itself. Yet, with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. The Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever change his life. While working on the UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally enter the direct path of a proton beam. The beam, with an energy level that defies belief, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was extraordinary. He saw a flash brighter than 1,000 suns but felt no immediate pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the medical center for treatment. The aftermath was both horrifying and remarkable. The beam caused localized tissue damage, resulting in hearing loss in one ear and partial facial paralysis. Astonishingly, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy. It serves as a reminder of the immense power and potential risks of particle accelerators. The dangers of a particle collider like the LHC should not be underestimated. The potential for catastrophic reactions or alterations to the fabric of existence itself are not the stuff of science fiction but genuine concerns voiced by respected scientists. One of the most unsettling and fascinating risks associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuums, devourers of stars, mysterious entities lurking in the shadows of our universe. The idea that the LHC could create such a phenomenon, even on a small scale, is staggering to both the public and scientists alike. Could this black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and would disappear almost instantaneously. However, the remote possibility has sparked debates, fears, and a sense of awe at the power we wield. It's crucial to understand how the LHC might create a black hole. It relates to the basic mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends. If the object is heavy enough, it could create a deep indentation, a point where even the trampoline's fabric tears. This is an analogy for how a black hole might form, a concentration of mass and energy so intense that it causes a rupture in spacetime. But in the case of the LHC, these theoretical black holes would be microscopic, with lifespans measured in fractions of a second before they decay into harmless particles. Still, this raises an important question. Are we playing with forces we barely understand? The creation of even a fleeting black hole forces us to confront the limits of human knowledge and the potential dangers of overstepping our boundaries. The line between scientific discovery and existential risk has never been thinner. But black holes are just one piece of the puzzle. The LHC's experiments also delve into the mysteries of dark matter, dark energy, and the fundamental forces of the universe. Dark matter, which makes up about 27% of the universe, is invisible yet exerts gravitational influence on visible matter. Dark energy, even more enigmatic, is believed to drive the universe's accelerating expansion. By smashing particles together at unfathomable speeds, scientists hope to glimpse these elusive phenomena and understand the very framework of our cosmos. In doing so, they may uncover answers to questions that have baffled humanity for centuries. What is the true nature of reality? Are there dimensions beyond the three we perceive? Could parallel universes exist alongside our own? These questions drive the work at CERN, pushing the boundaries of what is possible. However, not everyone shares this optimism. Critics argue that the pursuit of such knowledge comes with unacceptable risks. They point to scenarios where unintended consequences, such as the creation of stable black holes or other exotic phenomena, could spiral out of control. While these fears are largely dismissed by the scientific community, they serve as a sobering reminder of the stakes involved. Beyond the scientific and existential risks, the ethical implications of CERN's work must also be considered. Should humanity push forward in its quest for knowledge, even if it means risking the unknown? Or should we exercise caution, acknowledging that some doors might be better left unopened? These are questions that challenge not only scientists but also philosophers, ethicists, and society as a whole. In many ways, the LHC is a metaphor for humanity's relentless curiosity. It represents our insatiable desire to understand the universe, to uncover its secrets, and to rewrite the story of existence. But it also serves as a cautionary tale, a reminder of the delicate balance between progress and prudence. The experiments conducted at CERN hold the promise of revolutionary discoveries, yet they also force us to confront our deepest fears and uncertainties. As we stand at the precipice of scientific exploration, we are faced with a choice: to move forward boldly, embracing the risks, or to step back and reflect on the consequences. Perhaps the true test of our humanity lies not in our ability to create and discover, but in our capacity to choose wisely, to wield our knowledge with care and responsibility. In the end, the work at CERN is not just about particles, black holes, or dark matter. It is a reflection of who we are as a species. Curious, ambitious, and unafraid to explore the unknown. The journey may be fraught with challenges, but it is also filled with wonder and the promise of a deeper understanding of the universe and our place within it. Well, so profound that anything close by would be brought into it. This is a similarity for what could occur at the LHC in the domain of quantum physical science, where the laws of the universe are both odd and wondrous. There is speculation that extra aspects may be concealed within our existence. In the event that these aspects exist, the LHC's examinations could take advantage of them, creating a gravitational well that forms a small black hole. This bizarre dance of particles has even grabbed the attention of several highly regarded scientists, particularly the late Stephen Hawking. In his book, he cautioned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic event known as a vacuum decay, an event that wouldn't just destroy the Earth but might potentially annihilate the entire universe. The respected English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the possible risks of particle smasher tests, including those at CERN. His words weren't cautious. They were filled with a sense of existential dread. He examined a worst-case scenario where a failed experiment could trigger a phase transition that would resonate through the fabric of spacetime, resulting in a disaster that could engulf the entire universe. Rees's concerns weren't limited to theoretical ideas. He assigned a low probability to these terrible outcomes. Still, he argued that even a small chance warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The scientists at CERN have run simulations, analyzed the theories, and taken precautions to ensure the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of these measures. Recognizing the inevitable concerns and doubts surrounding the LHC's activities, he emphasized that there are rigorous safety protocols in place, thorough reviews, and procedures to ensure the LHC's operations are carried out with the highest level of precision. Cox reassured the public that the energies involved are well within what the Earth naturally encounters, and that the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so small and unstable that it would dissipate quickly in a burst of energy, a phenomenon predicted by Stephen Hawking called Hawking radiation. It would be a fleeting moment of cosmic wonder, a brief glimpse into the deep unknown, and then gone. Some have taken the idea even further, speculating that the LHC's experiments could open a doorway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many and become a topic of intrigue, fear, and even myth. What lies beyond our universe? Could we accidentally unleash forces or entities that we don't understand? The idea of creating a portal to hell has even been sensationalized in various media, fueling uncertainty. But how did this idea come about, and what does it mean in terms of scientific exploration? The concept of extra dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they could, in theory, be accessed or revealed under extreme conditions. Now imagine the LHC as a giant key, unlocking doors that have been locked since the dawn of mankind. When protons collide at energies never before achieved on Earth, they could, in principle, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC could indeed reveal them. However, before we get carried away with wild speculation, it's important to understand that while the LHC is certainly powerful, there is no definitive evidence to suggest it will open a portal to another universe, let alone to hell itself. Nonetheless, The allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of global catastrophe. But the truth is, the scientists at CERN are acutely aware of the risks involved. They have taken every precaution to ensure their experiments are safe, and they continue to monitor and evaluate their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly remarkable. It's not only a testament to human ingenuity but also a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we should approach it with a sense of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Yet, despite rigorous safety measures and detailed simulations, the LHC still evokes a sense of mystery and fear in some. The sheer scale of the machine and the energy it generates are awe-inspiring, and every new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are undeniable uncertainties. What if new, unexpected anomalies arise that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As particle collisions replicate conditions unseen since the Big Bang, the significance of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nevertheless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Ultimately, the quest for knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into realms of physics where intuition no longer applies. For centuries, physicists have sought to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a vital role in the formation of matter.